Hello and welcome to the lecture about hash table implementation. Today we will discuss about codes. Although hash tables or hash maps in Python are implemented through the built-in dictionary data type, but keep in mind that this lecture tries to give you a deeper understanding about hash tables by implementing details regardless of dictionary data type in Python. Let's get started by explaining codes. Initially, we have four functions. The first one is the main hash function, and others are operations such as insertion, search, and remove. The main function that we're going to use is a division hash function. You can use anything as you wish. The next function is insert data function, and we can push the data into the hash table by this function. The next function is search function to look up for a given item in hash table, and finally the last one is remove data function. Let's get started by creating a list of buckets holding the data. In the beginning the buckets are empty, but the size of the hash table is 10, so we have 10 empty buckets. And in the following lines, we have some data to insert into the hash table. The name of the fruits and their calories must be inserted into the hash table. To picture the steps better, I decided to change the view of the hash table from horizontal to vertical. In the first line, we call insert data function, and from the first line of insert data function, we conclude that we have another function. First of all, we need to know the index. Therefore, call getHash function and calculate ASCII code for banana. After finding ASCII code for each letter and adding them up, then we need to extract the remainder. In each iteration, this function will calculate the ASCII code for each letter. If it's a little bit confusing for you, then I highly recommend you to go and watch one of my lectures that is related to types of hash functions. 9 is the remainder and the function returns this value. Go back to the insert data function and check whether bucket is not empty. The bucket is empty, then go to and execute else condition. And then insert key value pair in corresponding bucket. Do the same for all data. The next one is apple. We can easily find its corresponding index. Then we must insert that into the table. Insert apple at index 0. Insert pineapple at index 8. And insert watermelon at index 6. Go to the next line. But be careful when inserting lemon, because lemon and banana have the same index. The produced hash value for both of them is the same. Then our code must handle collision. This code handles collision by chaining. Therefore, as is observed from the codes, it is evident that if there are any item in the bucket, then we should use append to add new key value pair in the corresponding bucket. Now it's the time to go for another operation, which is search operation. Suppose we want to look up for lemon. Call search function. And again, we need to call another function, which is our main hash function, to retrieve the corresponding index. In each iteration, we calculate the ASCII code for each letter. Based on the ASCII code of each letter and extracting the remainder, we can find out that corresponding index is 9. Go back to the search function and check whether bucket is not empty. Then go to the next line and initiate for loop. Based on the calculated index, we know that we have 2 items there. So I start from 0 to 2. Then go to the next line and check whether the key is within our bucket. To understand it better, let's translate this line of code very simply. It says, okay, let's go to the hash table. We know the index. Index is equal to 9. So go to the index 9. And from that bucket, extract the first element, which is located at index 0. And from that pair, extract the first element, which is banana. Therefore, we didn't find lemon. So go back and increment I to check the next pair of the key value. Now I is equal to 1, and we check the second key value pair in bucket that is located at index 9. That's it, and we found a lemon in the bucket, and now we can return its value. Go back, and this time we want to remove a key value pair in the bucket. Suppose we want to find banana and delete the key value pair in our hash table. Call remove data function, and in the first line again we need to call get hash function to calculate its corresponding index. Banana is located at index 9. Then we go to the bucket that its index is 9. In the first line, we check if the bucket is not empty. If not, then go to the following line to initiate a for loop, and then go to the next line to check if the key of the first pair is equal to the item that we're looking for. As is observed, we found banana, and we can simply remove it from the bucket. And then return a message to show the item is removed. That's it, and I hope you enjoyed this lecture. I tried to give you an intuition behind the hash table. Thanks for watching this lecture.